All right. Okay, yeah, let's get started. Hi, everyone. Um, yeah, so welcome to the launch event for this Encode Hackathon, sponsored by the Solana Foundation. So let's get started. I'm sure you guys are all excited as I am. My name is Angela. You probably have seen emails from me coming in. I am your program manager from Encode. So my job is to make sure everything is running smoothly. I am your first point of contact at Encode, and any questions you have, just ping them my way. So before we talk about the hackathon, I want to talk about Encode Club pretty quickly. So about Encode Club, we are a Web3 education community. So what that means is we help developers build their skills and find a career path in the industry. How do we do this? Well, we run various programs for devs at various stages in their careers to learn and build in Web3. So, for example, the hackathon that you're currently in. We've seen over 20,000 devs come to our programs, and our community is only growing. We also help devs find jobs within Web3, whether through placing them in companies or helping them grow into successful startups. So that's us at Encode. What are we doing today? Well, we are running this awesome 4-week hackathon created by Encode and Solana together. So the goal of this hackathon is to build on Solana, making this a hackathon with endless possibilities for projects, and I'm really excited to see what you guys build. Before we get into the details, I'd like to welcome Anthony, CEO of Encode, and Chase from the Solana Foundation to speak a few words. So, Anthony, do you want to go first?
Yeah, absolutely. Hi, everyone. Thank you so much for joining us here. Momentous for two reasons. One, this is a big hackathon after a ton of educational work we did last year. A number of you attended the boot camps and the education series as well. Two, because for long-time Encode community members, new platform, which should be reflected in some nice production standards when you rewatch the videos and perhaps rewatch the Crash Course workshop a bit later tomorrow. What to say, really, guys? We are always excited to see what you guys build. The creativity of the Encode community, I would like to say, is unrivaled. The amount of startups we've produced and just the cool things you guys do and the futures you go on to carve in Web3 are going to be great. They have been great, and I can't wait to see this time round. A big thank you to the Solana Foundation for their support for this and previous programs. I get the pleasure of saying they are a long-term partner, or rather have at the very least supported us for the long term. And Chase and the team have been great with us, and that's what helps make these events happen, really. But what we're all here for is the technology, particularly at this market timing. Actually, we want to forget about the market. It's about great technology. That hasn't changed. It's only getting better. And we look forward to seeing what you can do in this extremely broad hackathon. Basically, do whatever you want, so long as it's broadly within a Solana technological framework. But we look forward to seeing what you do, and please do interact with our team. One of the best things about an Encode event is we're extremely hands-on with you. We want to get you on calls. We want to be meshing with you. We want to provide a much more tailored hackathon experience than you've probably ever had before, and be part of your educational journey. That's enough from me. I will probably see you in 4 weeks' time when we see all the great things you have built. Now, the chat already is welcoming him. Let's hand over to the main man, Chase, for a few, I'm sure, inspirational words.
Hey guys, great to see many of you again here. Everybody who made it through the original boot camp, congratulations. To the ones who weren't participants, did not participate, welcome. This is our second time working with Encode. It's been a great experience. I've met many developers who came out of this program and really said that they enjoyed the experience fully. I think this is actually, there was another hackathon that was done, I believe, in Texas a while ago, but this is sort of like a little more organized version of that. So really excited to kick this off. Like Anthony and everybody mentioned, like this is pretty broad. We didn't ask anybody to build anything specific. If you are trying to get your sort of like technical chops up pretty quickly, if you go to solana.com/developers, I'll share this link here in a second. We have a curated list of like content and education. There's reference implementations. Solana Cookbook is a very important tool for reference code. There's lots of open source repositories that you can seek for inspiration. And then there's another product called build.superteam.fun. And this actually is a list of inspirational things that could be built on Solana. You're going to learn about this a little bit later, but like there's tools you can build with payments. There's something called Solana Pay that makes it really easy to do payments on chain. And there's a ton of different things out there. So again, solana.com/developers. And then I guess it was already shared, but and then build.superteam.fun has a ton of inspirational things and ideas that might sort of kickstart something in your mind that gives you an idea how to move forward. I know as developers, sometimes like building stuff is easy, but building it is easy, but figuring out what to build is not always the easiest part. But even if it's something simple, you want to build a wallet. Tons of people have already done wallets. Why not make your own wallet in your own flavor? Like, don't overthink it. Don't really try to like solve world hunger through this program. Just build something, ship it, get to the end of this, and then after the hackathon's over, continue on, and hopefully we'll see you guys at one of our hacker houses this year. Solana.com/events is going to be a really great place for communities. We're doing them globally. They kick off in Turkey in February, and then we're in Southeast Asia and Europe throughout the rest of the year. So if you have the opportunity, they're totally free, outside of accommodations and flights, of course. But if you're in those local areas, it's a really great experience with hundreds of builders, a place to learn, network, maybe find a team. There's all sorts of different opportunities there. And then beyond that, I'll make a mention is that every year we do 2 to 3 global hackathons, usually one in Q1 of the year. So probably one of those is going to be coming up soon. And once you sort of get your initial project rolling, I highly recommend that everybody join our global hackathons. The number one reason is these things come with $3 to $5 million in prizes and VC funding. A lot of people's lives have changed. They've been able to go full-time into Web3 specifically because of this. The summer camp is the old one. If you go to solana.com/hackathon, you'll actually be able to sign up for the mailing list to get an alert the next time that one of our global hackathons kick off. Like I said, they are super big opportunities for anybody who's ready to leave their Web2 job and get into Web3. These provide amazing opportunities. But again, thanks for having me. Thanks for being here. Thanks for being part of this, and good luck. Thank you, guys.
Awesome. Thank you, Jace. It's always a pleasure to have you on with us. Okay, so let's move on. So what happens during the hackathon? So for some of you, you've been to hackathons before, you know how it works. But for a lot of you as well, this is your very first hackathon. And I'm really excited to be your program manager and help guide you through this awesome event. So right now, hopefully everyone has signed up and has received an onboarding email with all the details for the event. If not, there's still time to register and even get your friends involved as well. So as we begin, you'll start to form teams if you haven't already. There's still time to do that. We have a lot of solo teams in this hackathon, but we also have established teams looking for people to join them. So if you are looking for a team, we have a dedicated Discord forum channel to help you find one. So throughout this hackathon, we will continue to run workshops in the next few weeks to help give you the technical skills needed to build your projects. And in 4 weeks' time, hopefully each of you will have a project to submit that you've worked really hard on and are really proud with. So we also provide support throughout the hackathon. We'll be doing the usual workshops and having opportunities to ask technical questions on Discord, or like pinging me or pinging Chase through us, I think. So I will also be around as your program manager to provide one-to-one mentorship and support as your projects develop. I know a few of you already have messaged me to set up meetings, which is really awesome. You can talk to me about anything you need regarding the hackathon, and I will do my best to answer your questions or point you in the right direction. So on to challenges and prizes. I know you guys have been looking forward to this. This hackathon challenge is pretty broad. It's to build on Solana and to build something innovative and useful. The prize pool is $10K in dollars and will be distributed based on the judging at the end of the hackathon. Because this challenge is so broad, there are so many possibilities for you guys to build and so many use cases. So I'm really excited to see what you guys are going to build. So on to frequently asked questions. Who can take part in this hackathon? Anyone, literally anyone you want. Get your friends involved, there's still time. Do you need a team? No, you can work solo, or we can help match you with one, again, on that Discord channel. Can you enter an existing project? Yes, as long as you show that you've introduced significant feature improvements, so that you're not just slapping something else on and hoping for the best. We want to see you actually build and develop and grow your project. Where can you find other resources for this hackathon? So if you've registered, you should have been sent a link to the Hacker Pack. That has all of the details that you need, all of the links, all of the sort of pointers to the right direction. So go and check that out. And where does the organization happen? All of our sort of communication is on Discord, so make sure that you guys have joined that channel. Again, that link is in the onboarding email that I should have sent you guys if you've been registered. And finally, will there be technical support? As I said in the last, as I said earlier, yes, there will be technical support. We'll be here with the workshops and the one-to-one mentorship. And yeah, we're here for anything you need, really. We really want you guys to succeed. So we want to be there with you on your journey. Onto the key dates. So a quick recap of this. So our first workshop is actually today, following this event. The following workshops, so the first one is building on Solana, the Crash Course. But following this, workshops will be announced as we go along. So the next one, the next couple will be on the 16th and the 17th of January. I will be sending you emails with these dates soon. And of course, if you have a specific topic you want to talk about or want technical help with, always drop that on the Discord channel and we will be able to help and get you some support. So we have 4 weeks until the submission deadline, and following that will be the finale held a little over a week after. We will send you information about this closer to the date, but for now, let's focus on the next steps. So make sure that you've joined our Discord channel. Again, that's where all of our communication happens, so we want to be able to stay engaged with you guys. If you're looking for a team, make sure you're using that dedicated Discord forum channel again. Participate in the workshops. So we've got the one today, we've got the ones coming up. If you can't make them because of time zone issues or whatever, we will be posting the workshops up on our YouTube channel, typically within a working day. So you can find them there, or you can rewatch them as many times as you'd like. Finally, you can get going with your projects as soon as you want. There's no need to wait for all the workshops to be done. Get going if you're ready to. And I'm just super excited for this hackathon. So if you have any questions, feel free to drop them in the questions tab below rather than the chat so that we can see them. I think we have a bit of time for answering questions. Anthony, what do you think?
I think, depending on Joe's availability, we can probably go straight in here. I will take some of the ones quickly when boot camp is. We haven't agreed it yet, but definitely on our roadmap. I think we might put one in for Q2. And I think Joe says he's ready, so I'll take these, and we'll get Joe off onto the stage, etc.
Okay.
Lots of stuff about the hackathon itself. Recordings go up. For you guys, doesn't go up publicly. Only goes up to people who are registered for the hackathon. So if you're not registered for the hackathon, please make sure you do so. If you haven't registered already, that's absolutely fine, but please do so as quickly as you can. The link is just on the website via a type form. You can still join people soon as well. That is a good point. Also, if you're in the hackathon, you will get a private place for the bootcamp as well when we next do it, because you've clearly showed willing by joining the hackathon. Otherwise, I think we can take everything in DM, or rather on this chat here. The last thing to say, guys, is that please do tweet that you are here, tag us and Solana developers. I don't know why my camera went weird there. And we will hopefully retweet you from the main account. So give you some nice followers as well there too. Oh, someone's actually used the question tab. What are the hackathon tracks? We kind of believe in having nice broad tracks, really. So you can build whatever you want. We've got a, oh my God, that's a cool feature. Music lifestyle. I've got something on my head. Wonderful. Which basically prizes just for the best project. So you can build whatever you want. I will be doing an ideation workshop on Tuesday, where I will suggest some things I think you should build, some cool things from the community, and maybe a little bit inspired on the investment side as well. I've got loads of upvotes. If you've got any potential ideas, you can also DM us. Top of the Discord, anyone in blue is DMable that question thing is cool. Everyone wants to put a question there just to vote it up. That'd be quite good. Cool. I reckon we are should hand out to bring Joe up to the stage and get started with the workshop. Why not use the extra time accordingly?
All right, cool. So how's it going, guys? I'm Joe. I'm from the DevRel team at Solana Foundation. And Chase gave a pretty good intro, so I don't have to go through all the stuff, but definitely worked with Encode before. You guys are doing a great job. And I'm happy to be here, happy to be putting on this workshop for you guys. And without further ado, what we're going to do is we're going to cover a beginner crash course, which is basically going to give you everything you need to know to build on Solana. So we'll see like transactions and wallets and stuff like that. We'll see some token stuff and NFTs, and we'll see writing your own custom smart contract. So let's go ahead and dive into it. And if you have any questions, put them in the chat. I'll do my best to answer them as we go. But all right, so here's our presentation here. And we're going to start by going over some basics about Solana. So the first thing is I want to share with you guys these links here. I'm going to put them in the chat as well. But the first one on the left is going to be the link to the actual workshop. And then the other ones, we'll talk about some more. Solana Playground is basically like an IDE that lives online. So like if you don't have anything installed for Solana or for Rust, that's a great way to actually be able to use that, like all of those tooling without having to install it locally. So it's basically designed for writing smart contracts, but you know, you can do some other stuff too, and they're adding new features to it. So it's really cool. Links are in the chat, but again, you can also use the QRs. And then, yeah, the cookbook is also a really great resource. It has like a ton of guides and some code snippets and all this cool stuff to get you guys started. So some of the code that I'm going to go over is inspired by some cookbook stuff. And you'll see in the workshop that I linked, the README also has everything that I'm covering right now docked out and with some links to cookbook and stuff like that. So, you know, you should have everything you need to kind of like retain all this stuff from the workshop. But so yeah, links are in the chat. So I'm going to go off this screen now. But cool. So the first thing we want to cover on Solana are Keypairs. So before I dive into this, I think you guys all know a little bit about Solana, right? Like, you know why Solana is such a competitor in the blockchain space. It's really fast. It's, it has a pretty unique way of storing state. And, amongst other things, there's a lot of really cool benefits. And so when it comes to building dApps and things for your hackathon, it's really handy to have a fast blockchain that's also really inexpensive on gas fees, right? So, you can just imagine the kinds of things that you can build versus something like Ethereum, where you have to consider these costs in any of your design. So we're going to start with the basic fundamentals. For those of you guys who aren't super familiar with crypto, Solana utilizes Keypairs like other blockchains do. And this is basically how your wallet works, right? So like you've got two keys, you've got a public key and a private key. And basically the private key is designed to sign transactions or messages. And then the public key is the key that you can share publicly, which is why it's called public key. And it can be used to decrypt what your private key has encrypted. And so therefore, if you know that you're able to decrypt something with my public key, you know it was signed by my private key. And signing just means it hashes it using a cryptographic algorithm. So that's a little bit of a TLDR on Keypairs. Basically, this is how wallets work in crypto, and particularly on Solana. And you can see down there, I just have like a CLI command that comes with the Solana toolkit for creating those key pairs. Now, before I go any further, I just want to mention to you guys, there's going to be some code that you can pull down from the workshop repo that I shared with you guys. And the only thing you should need is Node.js, and you need to have the Solana CLI installed. So those links can be found in the repo itself, but I'm going to just share the install Solana link as well. So you can get that stuff set up locally. Hopefully you've already got it. Maybe you've already started building a little bit or whatever, but that's how you install the CLI. And then you'll be able to actually run the code that you'll see in TypeScript. So anywho, these are how wallets work. And this is the first fundamental concept to understand is you basically have two key pairs, or you have a key pair for your wallet. And then to actually create a wallet on Solana, what you have to do is register your public key with the Solana network. And that's done by what's called the system program. So the system program is one of many native programs that live on Solana. And basically, the system program is responsible for kind of like managing new accounts. So it can register public keys as blockchain addresses, which we'll talk about in a minute. It can allocate space at a particular account's address, and it can change the ownership of an account. And we'll talk about ownership in a second as well. I'm going to quickly check the questions here. Okay, that's just the old one. Sounds good. All right, cool. So that's how the system program works. Like I said, there's many native programs like the token program, which we'll talk about later. There's some other programs that do particular like core operations on Solana. And as you guys get deeper and deeper into like the dev space on Solana, you'll kind of learn what these things do. But what you basically need to know is they're smart contracts that are native to the network. They are already deployed and live there. Most of them were built by either the community or Solana Labs, and they manage particular like operations for state that are fundamental to Solana. So the system program, remember, is how you basically create new accounts. And that's what that whole like registering process is doing. So let's take a look at accounts here. One thing to understand about Solana that's unique compared to other blockchains you might have worked with is that everything is an account. And if you think about like a Linux file system, I'm not sure if you guys know about Linux file systems, but basically you can see from the diagram, everything on a Linux operating system is a file. And that comes in really handy because it's really simple, right? Like everything that you're going to do on Linux is a file. You might have a program that's comprised of many, many files, but ultimately everything boils down to a file. So in a sense, you can think of the way Solana indexes state data as pretty similar to a Linux operating system. There's obviously a ton of caveats there, but that helps to kind of like picture what's going on. So any index of data that you're storing on Solana's blockchain goes into what's called an account. And that account has an address. And that address is how Solana's runtime will actually find the data. So back on the previous slide, when I said that like you're going to register your public key as a blockchain address, that's what you're doing. And when you do that, it will create an account at a specific location on the blockchain defined by the address. And it'll basically have these 5 fields. So you've got LAN ports, you've got owner, executable data, and rent epic. Now, I see we have a question in here. Yeah, we'll have a recording. So anyway, as you can probably figure out, if you don't know what LAN ports are the smaller denomination of Sol. So like Ethereum, the ETH token breaks down to like Gwei and Wei. Solana Sol breaks down to LAN ports. And it's like 1 billion or like 10 billion. I forget exactly how many LAN ports are in a Sol. But it's the smaller denomination, and it's all recorded in LAN ports on the runtime. So that's all that means. It's just the balance of that account. And since Sol or Lamport is the native token, every single thing, yes, Lamport is like Cent kind of, it's just way smaller. So every single account that you have on Solana has a Lamport balance. And that actually ties into the rent field, the rent epic field. So one thing that Solana kind of utilizes for the moment, and they're actually in the process of maybe changing this, is when you want to store data on its blockchain, you have to essentially pay for it. You have to pay what's called rent. And if you think about it, it kind of makes sense because all of the state data that's being stored on the chain has to be distributed across all the validators' hardware, right? And they pay for that. So like there's kind of like a system going where like depending on how much of that hardware space you aim to take up, you have to pay rent. Now, one thing that Solana engineers kind of like put into place earlier in 2022 was the idea of rent exemption. In fact, I think it's older than that, but now it's like, it's a little bit more of a standardized thing. If you put in 2 years worth of rent, your account doesn't get charged rent. So it sounds kind of silly. And to be honest with you, maybe it is, which is exactly why they're working on improvements on that. But for now, all you have to know is based on the size of your account, you're going to get charged a certain amount of rent, and you have to keep that amount in your account's balance to prevent any kind of withdrawals to pay rent. A little confusing, but again, it's explained in the workshop, like README and stuff a little bit more. But when you go to see the code, you'll see exactly what I'm talking about. And we'll show that in a second. So the other three fields, executable is just a Boolean. It means, is this account a smart contract or no? Obviously, if executable is true, that means it is a smart contract. And yes, I saw your message in here. Everything is account. It literally is. Everything is an account, including smart contracts, which is why you have the executable field, because even your programs are accounts. Just inside those accounts lives a smart contract. So literally everything on Solana is an actual account, from smart contracts to your wallet to any kind of custom data, all accounts. And then the data field is just your own custom data. So like these are the default fields that come with every single Solana account, no matter what. And then inside that data field is what you've custom put in there. So if it's a smart contract, that's where your smart contract code lives. If it's just like a data storing account, like if you're keeping some fields about like a person's information or whatever, that's where it gets put in, and it's in the form of bytes. And the last field that we want to talk about is the owner field. So this concept can be a tad confusing at first, but basically on Solana, every single account is owned by a smart contract, even smart contracts, right? Like they're owned by a program. So default, when you have like a Solana wallet, like if you set up like a Phantom or a Soulflare or a Glow wallet, even for the first time, that wallet, even though you hold the keys, is owned by the system program. And the system program is designed to make sure that you have signed any changes to that account before. So like if you think about like sending Sol to somebody, like the system program in theory could just take Sol from your account if it wanted to, but it's written in a way that you have to sign that transaction, and it'll check to make sure, like we talked about with the Keypairs, that your private key did in fact sign it. So it's protected by your private key. But the reason I bring that up is because if you write your own smart contract and you have accounts that are owned by your own smart contract, your smart contract can take Sol from those accounts at will with no permission. So it's really important to remember when we get to program stuff later that you got to add really special safeguards to make sure that those accounts can't be compromised. Where can I get more info on rent exemptions? So I will go ahead. Actually, I think I linked it in the workshop README. Let's see. I'm checking right now. Okay, it's not linked there, but basically the Solana docs has a pretty good overview of rent, which I will share in the chat right now for you. Yeah, it's a little confusing, and it has changed time to time, and it will change again. But here it is in the chat for you guys who want to reference anything about rent on Solana. Anyway, so I think you guys get it. I really can't stress this idea enough that everything is an account. But let's start getting into like some of the coding stuff, right? So, we're going to talk about actually interacting with Solana. So I talked about in the previous slide the accounts, and here I'm going to actually look at some of the code. So I've got the workshop repo opened up. This is the one that I linked you guys to. We're in the beginner crash course workshop, of course. And if you head into the client examples, we basically have a number of TypeScript scripts. And so you can see here, like there's some util stuff. So like the one thing I want to call out is you want to have Solana installed to run these locally, because this is what's going to load your local wallet key pair. And that's going to be designed to pay for transactions, which we'll talk about in a minute. And then this log file is just a bunch of print statements. You don't really have to worry about it. And then transaction, we're going to cover this in a minute. This is how you build a transaction. So I will come back to this. But first things first, if you look at the account script, this is where we actually are going to create a new key pair, right? So we're going to use this keypair.generate to create a new key pair. But like I said, that public key has to be registered with the Solana network first before it can be activated as an account. So like you can create key pairs all you want. It's just a default library for creating key pairs. I don't exactly remember which specific library it is, but it's just like creating a new SSH key pair. Like it's not going to do anything until you put it into some kind of like place where it's going to be used. But you can still create key pairs all you want. So we're going to generate this key pair here. And then, we'll talk about the transactions, because the first thing we're going to see is how you actually go ahead and create an account, which is going to be registering that new key pair's public key with Solana. So going back to transactions here, I just want to talk quickly about how you interact with the Solana network, and then we'll step through all that code. So the first thing is you use RPC requests to communicate with the Solana network. If you guys are familiar with HTTP requests, it's pretty similar. There's some notable differences, but when you're writing code, you honestly won't necessarily notice too much of a difference until you get into real complex builds. So you can think about it just like a GET or a POST request. So if you think about a GET request, you're going to make an RPC request to Solana network and ask for some information. And that's going to be like a query. So if you wanted to look up like, what is my current SOL balance, you would make an RPC request to the network, and it would return to you a response with whatever it is you've asked for. In this case, your SOL balance. If you want to change data on the Solana blockchain, equivalent to a POST request, what you actually have to do is you actually have to send an RPC request with a transaction. Now I'm going to quickly check the questions, and then I'll cover transactions. Is it possible to layer dApps under pre-existing apps? Yeah, so we can circle back to this later, but yeah, what you could do is you can basically integrate applications that are Web3, so like that are interacting with the blockchain, into your own app. Like one example is like if you had a microservice architecture, if you guys know what that is, you could have your app running, and then it could just communicate with your dApp. But what you'll see in this workshop is that dApps don't live on chain. The only part that lives on chain is your smart contract. So without confusing people, what you want to do, I think, is totally possible, and we can come back to that later. But yeah, so anyway, I'm going to continue with transactions so we can start covering some of this code. So transaction is just really like a message payload that you're going to send, which is why I said it's like similar to a POST request, because it's a prefabbed payload that is designed to communicate with the Solana network. The network is designed to receive these, and they follow a very specific format, which you're going to see on screen here. So on the left, we have a transaction. So the transaction has a list of signatures and then a message. And the list of signatures are just hashed versions of that transactions, hashed by your private key. So we talked about signing earlier. Those are just signed transactions. And you actually, like, the network is going to take a look at those, and depending on what program you send the instructions to, blah, 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 it's going to make sure those signatures are valid. So we can ignore the header field. Oops. We can ignore the header field for now. The addresses field is going to be a list of public keys that are associated with this particular transaction. And then the instructions list is going to be a list of instructions, which are on the right. We'll talk about in a sec. I just want to quickly call out that every transaction uses this field called recent block hash. And what that basically means is when you go to send a transaction, it's required that you query the network and you get a very recent block hash. Most people just get the latest one, like the current one. And that's just the current hash that the blockchain is on. And the reason that Solana does this is because it's going to key on that block hash and make sure that not too much time has passed. So this helps prevent like fraud and like kind of like hacking maneuvers, because if this is a really old transaction, like A, you might not want it to go through anymore, and B, it could be malicious. There's a lot to that, but the point is it's a security measure. So when you create a transaction, you'll have to do that. And then in the instructions, you can see here, each instruction is pointing to a specific program using its address. Again, because smart contracts are accounts, they all have public keys, which are blockchain addresses. So you tell the instruction which program this is for. And then the accounts are, again, a list of all of the accounts that are needed for this instruction. So you can see that addresses and accounts are present in both payloads. It might seem a little redundant, but basically you include all of the addresses for the transaction because it's validated on chain and it's used to, figure out parallel processing. And then you also include them in the instructions because you can include multiple instructions in a transaction. So let's say you need like 5 addresses for one instruction and 3 for another, and let's say they're all different. You would put all 8 in the transaction, but you only need to include in the instructions which ones are for which. So that's why it's present in both spots. And a quick note on parallel processing. Solana actually makes use of parallel processing of state changes, just like a database would, which is one of the reasons why it's so fast. So the reason you're looking at this structure here, and the reason it's so strict is because what's happening under the hood is the runtime is basically going to look at the different accounts that you mean to change or use, and it's going to check to see if you're reading or writing. If you're reading, you can do all those reads in parallel, right? Because they're not changing. If you're writing, then it's going to lock them. And so with this mechanism, Solana is allowed to process state and instructions that are mostly either just reading or writing or whatever in parallel for the most part, right? With the obvious exceptions being any kind of lock conflicts. So pretty cool stuff. And the last bit for the instructions is the instruction data. That, just like an accounts data, is represented in bytes. And we'll see what that looks like later. But that's going to basically tell the program what to do. So you send an instruction to a program, and then one program might be capable of like a bunch of different program instructions. So like, for example, the system program, it can create accounts, it can allocate space, it can do all these different things. And you would send the instruction with the proper data to tell it which operation to do. And so again, we will see this as well. So let's flip back over here and let's look at building a transaction. And you can see what I just explained in code here. So we're going to get the most recent block hash by querying the chain using an RPC request. And so I'm passing in the connection as a parameter here. But if you look on this page, this is how you set up a new connection to the Solana network. So right here is all you need. In this case, I'm using DevNet, and I'm setting these 2 configs. So the confirmed config for commitment just means I want to get signatures back from transactions when I know that they've been confirmed in a block. And on Solana, that's only like a few hundred milliseconds, so it's pretty fast. So it'll actually, when you run like in a wait, it'll wait to make sure that it's been confirmed before giving you a response. And then I set the timeout to 60 seconds instead of the default for 30 because, sometimes like my Wi-Fi is a little slow, or sometimes DevNet is a little slow. So I just set that config as well. Anyway, going back to the transaction here, we use the connection to the network to actually query with an RPC request the latest block hash. And then we store it in this field. And you can see that when we create our message, just like we saw in the payload here, we are actually setting the payer of the transaction, the recent block hash, a list of instructions, and then the header is automatically generated. So then you just compile that into a version transaction, which is actually a brand new thing. I wouldn't really worry about how transactions were built previously. I would just focus on this setup here. And then we go ahead and sign it with every one of our signers that are needed. And we return the transaction. So that's what this function is going to do. You're going to see this thing used a few times as we go throughout the script. But let's take a look at some more code here and figure out exactly how we do some of these operations that we just covered, right? So going to accounts, we talked about registering a public key with the blockchain as an address. So that's the act of creating an account. And right here, that's exactly what that looks like, right? So, and by the way, if you guys need this to look any bigger, like if you want me to zoom in, just say it in the chat. But anyway, when you go to create an account, the first thing you want to do is check to see how many LAN ports this account needs to be funded with. Because like we talked about with rent, when you create an account, you need to fund it with enough SOL or LAN ports to pay rent. And there's actually a function for that. You can use an RPC request and you can get the minimum balance for rent exemption, which kind of ties into one of the questions that popped up in the chat here. This is a function that you can use to get the amount of rent that you need for a particular account size. In this example here, we are allocating a size with no additional space. So it's just going to have those default fields, no inner data. And so for that reason, I put a 0 here. And now this would be enough to fund, but I'm adding an additional 100,000 LAN ports because I want to later do some transfers, right? But this part right here is not necessary. This is just something I'm doing for example's sake. So then we just go ahead and run this right here. So you can build instructions manually, and we'll probably see an example of that later when we do some token stuff, possibly. Actually, no, we'll see an example of that when we do our smart contract. But most of the traditional operations that you're going to need on Solana, there's SDKs to build these instructions for you. So you don't have to worry about all the like different configs. And I did share this code, William. This is in the workshop repo link, which I will share again for you. Maybe we could pin it or something. But anyway, so yeah, when you run this create account function, you can see that it's going to return to you a transaction instruction. It's one of those many SDK functions that are designed to make that a little easier to build for you. So you pass in which public key is going to pay for the new account, what the new account's address is going to be, and I'm passing that in as a parameter because you'll see at the bottom, we're going to actually create a couple accounts. So this is going to be the new public key that we're going to register with Solana, that amount of LAN ports that we just figured out how much we need. And then finally, the program ID or the owner of this account. In this case, I'm going to use the same setup as like a traditional wallet on Solana, and I'm going to make the owner the system program. And then you can see right here, I'm just using my build transaction function, passing in a couple of things to have the key. So we have to also sign it to pay for the transaction, but we also have to add a signature from our new key pair as well. So you need both. And then we pass our instruction, and you go ahead and use that connection object to send an RPC request with that transaction, and that will actually go ahead and build the transaction and send it to create a new account. So I'm going to run this thing at the end, but I want to kind of like cover some of these code snippets. So that right there is how you create an account. And anything you see on here, guys, that says log, again, this is just like print statements. So you can pretty much ignore all this stuff, but this is going to be the meat and potatoes right here. So creating an account looks good, pretty straightforward. We create an instruction to do so, and then we send it in a transaction with the necessary signers. Pretty straightforward. And that pattern is going to be what you follow to do any Solana operation. So I want to just quickly call out that if you notice, we just created a new account without the use of a smart contract of our own creation. We're using the native system program. So again, I'm circling back to this because you can build full dApps. In fact, many people do, and they exist today, that you don't have to write your own smart contract. In fact, there's really a smaller number of reasons why you do need to write a smart contract than there is reasons why you don't, which sounds funny, but like, this is what I try to make this point to people, because like you can just kind of like rely on your JavaScript skills and your dev experience building JavaScript applications to get into Solana development. And you don't really even have to worry about Rust until you need it. So just keep in mind that like everything you're going to see here is just using native programs, and it's all packaged into this SDK. So like you can just use the native programs and the native instructions and run plenty of operations to build dApps. So quickly checking the questions real quick. Is there a Python module to interact with Solana? Yes, there is. This is not one created by Solana Labs, but there is a Python SDK that has most of this JavaScript SDK code in it. I'm going to share it in the chat. It's called Solana Pi. Again, not official, but that is going to be pretty much a mirror of this SDK in Python. So if you're more comfortable with Python, go right ahead and use that. Just be aware that it's not maintained by the same maintainers as Solana Web3 JS. Anyway, so going back to our examples here, let's take a look at some of these other like features in this code here. So we saw creating an account. And now if we want to query an account's data using an RPC request, like we saw with this guy here, right? Just like a GET request. And this is what that looks like right here. You can see there's no transaction involved. We're just doing a query, just like we did with, you know, querying how much LAN ports we need, querying what the latest block hash is. These are all RPC requests that are equivalent to GET requests. So you don't need a transaction. You can just ask it a query and it'll tell you. So in this case, we're going to query that account that we're going to query the account we just created, but this is a function that can be reused. So you can see down here, we're creating Keypair A, and then we're querying its data. And I'm going to try to run this, but I wouldn't be surprised if for some reason it doesn't work, because that's usually how it goes when you're presenting, right? So I'm going to go to client examples. And for any of you guys who have this locally, if you need to know, this is how you would run it. You just do a yarn install from within client examples. Actually, let me just double check how I laid this repo out. Yeah. And then you can do yarn run accounts. And this might take a second, so I'll give it a second. But anyway, yeah, like I said, so you can just hit the network with an RPC request for a query, and it'll return to you this account info object. And you can see that it wraps this buffer type. And that's because it's going to give you back the account info of all the different, you know, default fields that we saw in the slide. But the buffer is going to be the bytes that represent the inner data. And the reason that's defined there in the type is because you can do a parsed account and you can try to like deserialize that all in one step. That's a little bit complex and outside the scope of this particular tutorial. But for the most part, just understand that it's going to give you back that account info with the default fields, and your data is going to be in the form of bytes. So checking questions again real quick. In create account, which key pair are you referencing? So if you look at create account, I'm passing in a key pair, and down here, I'm going to run it, and I'm going to use that same function to create each of these, right? So start with A, then we query A, then we create B, and then we transfer from A to B. So that's what this script is. This is the script right here. And then all those up there are just the functions that it's using. Okay, so hopefully that clears that up for you, Jeremy. Anything else though, let me know. But yeah, so see if this thing decided to work when I ran it. Okay, now see, I have issues lately sometimes connecting to DevNet. I'll give it one more try. Okay, there you go. So it looks like it might be wanting to work a little bit. So created a new key pair, and you'll see how slow this is. You'll see why I did the timeout the way I did. But all right, so created a new key pair. There's the new account's public key. And then you can see the transaction was successful, and there's the transaction signature. So quickly, I'm going to show you guys actually what this looks like. Go to explorer.solana.com, which I'll share in the chat as well. This is what's called a blockchain explorer. And this is a really cool tool for looking at the data that you're actually modifying on chain. This is just an entire blockchain querier. So the first thing you want to do is make sure you're on the same network that you are going to be working with. Ours is DevNet, and you can see DevNet's a little dicey at the moment, but we're switching over to DevNet. And then let's take a look at the account that we just created, the public key. This might be a little slow because it looks like it's having trouble connecting to DevNet right now, but we'll see if that loads. But either way, you can look up the account by its public key, and you can also look up transaction signatures, which you'll see right here. Yeah, so DevNet, I think, is having a little bit of problems at the moment, which seems to happen whenever I want to conduct a workshop. But regardless, You can look up public keys, like I said, or you can look up transaction signatures, and it'll actually show you these on chain. What I'm going to do real quick, guys, and I don't expect you guys to have this thing set up, but if you download the Solana CLI, like I sent the link for earlier, you can actually run your own local validator node. And for reasons like this is really convenient. You can use testnet, yes, but I typically will default to the local net instead. The only caveat on local net is any programs that aren't like native programs, you have to import, which, you know, I'm not going to necessarily have time to do today, but we'll cover that later. Point is, you get all the native programs and a single node validator locally when you run this Solana test validator. So I just did that, and I'm going to actually switch this to local net by doing HTTP. It's going to be localhost 8899. Then I'm also going to just set my configs to local net, as you can see there. So now that this is set up for local net, this should be much faster and it should work. So we'll give that a rip. And then another cool thing about this, yeah, you see how much faster that was? You can actually use the Explorer to look at your local setup too, which is really cool. Like this will know that you have a local validator running and it'll just latch on to this localhost 8899. And then I can show you what I was trying to show you. We can take a look at this public key. You can see there's the account we created. And you can see there's our LAN ports balance there. And we can also see the transaction signature of when we created said account. So you can see it comes up as a transaction. And you can see down here, the system program was involved. This is our account that's being created and funded. And this is our local wallet that was being debited because it paid to create the new account. And that's why you can see it's called a fee payer. And then honestly, this has come a long way recently too. You can see the instructions involved as well. And you can see that create account was invoked, which is exactly why we created an account, right? So we sent the right data to the system program to tell it to do this. So definitely utilize the Explorer, guys. There's other ones too, like SoulScan. I'll share this link as well. And then there's Solana FM, which is kind of a newer blockchain explorer. These guys are pretty cool. They're actually working on a lot of cool stuff, which one cool thing I'll show you guys about Solana FM is if you search a transaction signature, let's see if I can switch over to local net. I'm not sure if they support local net yet. They might not. Okay, perhaps they don't. If they do, I'm sorry, Solana FM, I don't know how to do it. But basically, if you look at a transaction, it'll show you some really cool graphics about like what actually happened in your particular transaction. So just going to share the Solana FM link. There you go. All right. But we're going to use Explorer for now. But anyway, so yeah, so you can see it's a super powerful tool. And then when we queried our blockchain data for that account we created, there are those default fields that we covered, right? So exactly as we expected them to look. And you can see, again, like I said, the data is going to be a buffer. Now, we didn't put any data in there, so there's not going to be anything in there. It's just going to be an empty array of bytes. But if you added custom data, that's where it would live. And you would have to deserialize that, which we'll cover a little bit later. But anyway, you can see that like there's the public key of the system program, all ones. That's the owner, and you know, etc. So all that stuff is in there, not executable. And then down here, we're creating key pair B, like we saw. And then here's our transfer. So I'll come back to this in a sec. But the last function that we want to cover in this account script is the transfer of LAN ports. So yeah, so the transfer function then, again, we're using the system program and the functions that come with that object in JavaScript to actually build the instructions to create a transfer instruction. And you can see that it's boiled down to these particular inputs. So who's it coming from, who's it going to, and how many LAN ports. And this is exactly why I said I wanted to give that extra 100,000 LAN ports, because we're going to transfer 90,000 of them out. And then you build the transaction just like we saw before. In this case, we are going to pay for the transaction and we have to sign with the sender, right? Because it's a debit. But the sender is also going to be the one paying for the transaction. So in this case, we only need one signature. Now, if I was to change this to payer, which is our local wallet, then I would have to also add the payer as a signer, right? But I decided to make this particular key pair, since it exists and we created it, it can now pay for transactions because it has SOL. So I decided to use that as this fee payer for this example. But it's important to note that the person who pays for a transaction can be the one can be a separate entity than who's involved in the operation, right? So like I can pay for a transaction where you're going to transfer SOL to someone else as long as you also sign it, right? Like we both authorize it. Or you can pay for the transaction and authorize the debit. So, you know, both are possible. But anyway, that's the transfer function right there. And then I'm just checking the balances before and after. So you can see here, we got the 9908 for both. And then after the transfer, you can see it drops down to 895 and this goes to 1080. So transfer was successful. And then we can also look up our second account as well, just to verify on chain with the local validator node. And you can see same balance, 0 bytes for data, right? All the same fields come up because it's using the same functions that we are right here. All right. So that, guys, is the basics of accounts and interacting with the blockchain. So those are the core fundamentals of building everything on Solana. Those are the building blocks. The next section we're going to cover is tokens. I just want to slow down for a second to make sure that there's not any questions. If there's anything that I can clear up about this section, about accounts, about transactions, about SOL and LAMP ports, whatever it is, go ahead and throw those questions in there. I'll give you guys 1 minute to do that, a couple minutes maybe, and then we're going to move to tokens. If you need to use multiple programs in a transaction, you have to make a contract, I assume? No, actually. So if you look at the transaction format here, and if we look at it here, you can see that the instructions field is a list, right? So you can include multiple instructions in one transaction. In fact, that's usually preferable because it's going to be a little bit cheaper. And the way you determine different programs is with this program ID field. So if I have 2 instructions in one transaction, and one instruction is pointing to the system program, and another one is pointing to the token program, you can send them in one transaction and it'll go conduct operations on 2 different smart contracts. That's how you do it. There's no such thing as an instruction that points to multiple programs because it's not really how it's built. It doesn't really make sense, you know, like it's one instruction is designed for one smart contract. So that's how you do it with multiple programs. How does it know how to hook up the inputs and outputs? So the inputs are in the instruction data field here. So to give you an example, like the system program is capable of doing a couple things. So let's consider 2 operations that the system program can do. It can allocate space and it can create an account, right? Which are 2 different things. Allocating space, just, you know, that doesn't involve like actually activating an account yet. But let's pretend those are 2 different separate things. What the smart contract is going to do, and we'll actually see this later live in Rust code, is it'll have a processor inside of it, which is some code that's going to take a look at this instruction data field, and it's going to deserialize it from bytes into Rust code. And it's going to take a look at what instruction it is. So in a very basic sense, think about an enum. If you have an enum that has 3 different variants, and each one is a command, one is create, one is allocate, one is transfer, right? If I can take that instruction data, deserialize it into that enum, and determine which variant it is, then I know what to do, right? If the variant is transfer, I know that I'm going to conduct a transfer. Now, what the tricky part is the accounts that I'm supposed to use to do that thing. That's what it's put in that accounts field, that list. And the weird thing about Solana is they have to be in order. So like you have to know that the order you need to put the accounts in for a transfer is you need to have the sender, the recipient, and the system program, or the owner. In this case, the system program, because we're going to the system program. They have to be in that order. And the code on the smart contract is going to read them in that order. If you have them backwards, it will fail because it'll try to send from your recipient, but your sender will be the one who have signed it. So it'll give you an invalid signature error. But it's a little confusing. It'll make a lot more sense when you see the on-chain code later. But yeah, basically think about the instruction data as almost like an enum that tells it what to do. And then the accounts are the different like data records or files that are going to be involved in that operation. And again, that will all make sense later. So cool. Any other questions at all before I jump to tokens? And yeah, I just wanted to call out one more time, guys, like we are going to look at an on-chain program today. So like some of this stuff that you're seeing will make more sense. In fact, I think what I'll do is I will go to the on-chain program part next, and we'll come back to tokens. Since we're on instructions and transactions, probably better to do that. So let's talk about writing Solana programs, and we will see exactly, what I'm kind of talking about here in an on-chain sense. Program ID is the subroutine, and instruction data is the arguments. No, program ID is, I guess if you can think of like a two-tier subroutine. So instruction data is going to have both the subroutine and the arguments. And then the program ID is like routine, or like the thing that it's going to, like the program that you're using. I'll show you exactly what I mean right now. So in a program, when you write this in Rust, before I get into this, I want to share with you guys one more time the Solana Playground IDE. And this is going to be an IDE that you can use online to write Rust code and Solana programs. So if you don't have any of that installed, you can use this. I'm going to use it in this demo really quickly. So I'm going to use native Rust. I'm going to call this Crash Course. I'm going to create a new project. And then what I'm going to do, and this is just a bunch of boilerplate that the IDE will generate for you. I'm going to click this GitHub icon. And you can see that it tells you how to import for the different frameworks that you're using. And we'll talk about these frameworks at the end. I'm just going to talk about native today. What you want to do is we're going to cover the Hello World example right now for the Rust code. So if you go to Hello World and you go to program, which I'm going to pull that up on screen real quick. So if you go in here, you can see that there's the tests, there's some other files, and then there's program. And right here is the root of a cargo crate, or your Rust code, right? This is your root whenever you see cargo toml and src. And this is the URL that you're going to want to pass to the Solana Playground right here. You're going to have to hit import. And when you do that, it'll give you your Rust code. It'll pull it right from my GitHub repo. So go ahead and do that if you want. This is beta.solpg.io. I shared the link. The only thing you want to do is you want to make sure that you connect a wallet, hook it up to DevNet. I believe you can do LocalNet, if I'm not mistaken. Let me just see how I could do that here. I think you can. Yeah. So there we go. We're hooked into localhost. Which is cool. But you guys can use DevNet if you don't have the local validator. Hopefully those issues are kind of being resolved at the moment. But anyway, so here is the Rust code. And like I have in the presentation slide here, the structure of your program relies on what's called an entry point. And you can see here, that entry point is defined with this macro. And for those of you guys who don't know Rust, a macro is basically like an embedded process where you call with this like keyword and exclamation point, and it will build out a bunch of code for you. In this case, what it's going to do is it's going to tell Solana what function in your Rust code is the entry point of your smart contract. And the reason that you need to provide that is because if you look at the entry point we've defined, hello world, these fields exactly match these fields that we saw in a transaction, actually an instruction per se, right? It's the exact same ones. And that's the point, right? Like these instructions go to smart contracts. So your smart contract has to be written to take these in and do stuff with them. And so, like I said, we're going to take a look at exactly how that works right now. So in this case, we're not doing anything special, right? But this is just the general format for writing a Solana program. So I'm going to flip to VS Code so I can show you a little bit more of the repo itself, but feel free to keep following along in the SolPG. So if you look at the program folder, if we look at Cargo TOML, there's two things that are key. One is we need the Solana program crate, the dependency for using Solana code to write a program. And two is we need to define our Rust crate as a lib, and it needs to be a CDY lib. And that's going to allow us to use the Solana toolkit to turn this Rust code into the proper format so it can be stored as bytes inside of an account, right? So that's what this does. So you need both these things inside Cargo TOML, and then you're good to go. Flipping back to SolPG, if we take a look here, these are the different things we're going to use to import. And then, like I said, these are the necessary parameters because we're going to be receiving instructions at this smart contract. So now what we're going to do, just making sure you guys are okay in the chat. Okay. You can see MSG is a macro that's used for printing out log statements. And so in our case, I'm just going to print out hello Solana, and I'm going to also print out our program's ID. Now you can see I'm referencing the program ID parameter, and you might be thinking like, how do you know that this is our program's ID? Well, because an instruction on Solana is designed to send these parameters, if this instruction reaches our program, it's because the Solana runtime said, here's the program ID that was passed in the instruction, and it looked our program up by its address and sent us the instruction. The runtime is only going to send us instructions that are for our program. You can include it here because A, it's part of an instruction payload, and B, you can use it inside your code, right? Like it's a good way to kind of like reference the program's own address inside of itself. So there's an example of how you do that. And then this is what I was talking about reading those accounts. You have to set up an iterator on this list of account info, and then you can go ahead and iterate through that iterator and get all the accounts. In this case, it's just a pair. So a couple things. One, what's cool about the Solana runtime and building Solana programs is you notice that we, on our smart contract, are getting this account info object. But on our client side, when we sent this instruction, we're actually sending public keys. And you can see that in the like client side code right here. You can see that we're only sending public keys. So what happens is the runtime, because we talked about the whole parallel processing thing and the locking of accounts and stuff like that, the runtime is going to set up all that parallel configurations. And then when the accounts go to reach your smart contract, they're actually being loaded from the blockchain. So they're no longer just an address. They're now the full account info payload. So you get the default fields like the LAN port balance, et cetera, and you get the inner data. So pretty cool stuff. And that's exactly why you see this object instead of pub key. So once you do this, you can actually load that object up into an account info and you can do stuff with it. And you can see here, you can reference the fields. In this case, I'm just referencing the key, but you can also reference the LAN ports, you can reference the data, et cetera. So pretty cool stuff. Now, this is a pretty straightforward program. The next program I'm going to show is where we're going to talk a little bit about the instructions and the processing, some of the things you guys were questioning. But before I do that, I want to demonstrate something that I think is kind of cool. So what you can do is when you're using a local validator, you can just do Solana logs, and that will subscribe to your logs. And since it's just our local one node validator, there's not going to be any logs until we do something. So like, for example, if I go to like our program, spell, I go to hello world, and if I do Solana program deploy, And just by the way, guys, I'm going to demonstrate how you build this thing too. If you're going to, but it takes kind of a while with Rust sometimes. I think I already built this, so it might not take that long. But with Solana, the keyword is cargo build BPF. And in more recent versions of Solana, it's build SBF. But you should be able to use BPF, and it may convert you. Oh, wait, so I got to go to program, sorry. And then you can see that that's going to build. It's going to run cargo build, but it's going to utilize that cdylib config that we provided, and it's going to put it into the right format. And you can find it in the target deploy folder. Here's the key pair for your program's account, and here's your program code. And so what you can do is you can say Solana deploy, Solana program deploy. You can do target deploy program.so. And once I do that, that's going to send a transaction to Solana and tell it to deploy this program. And since we're working locally, you can see there's the logs for it. I was subscribed to these logs, and you can see all the different steps involved in, deploying a program. That's everything that it takes. That's the only thing that this is showing. The tricky part is if you do something like this and you subscribe to DevNet and you do Solana logs, you're going to just get nonstop logs. So a cool feature that you can do, which I'm going to demonstrate on LocalNet just because that's where I deployed my program, is you can do Solana logs and you can grep the name or the address of your program. So if we look at our deploy, it tells us the program ID. And this is just a little bit of like a CLI hack. Like this isn't necessary, guys. It's just if you're working with DevNet and you want to get rid of those logs and you just want to see your logs, this is a really good way to do it. And then I usually just say show like a dozen lines after. So that'll just sit there, subscribe to the logs, and wait for my program ID. And so in the case of my program here, I can just run my test. It's going to go hit my Hello World program. And even though we're local, apparently this is taking a little bit of time. So I'm going to show you guys what this client-side code looks like to hit our custom program. So in our tests folder here, we have this file here. Again, this stuff is the same as we saw previously with the account script. This is just our local pair. And now we're also loading our program, right? So like this is where we saw that key pair. And now here's how you actually create a raw instruction, which I don't know why this is taking so long. Weird. Oh, I know why. I didn't set this to DevNet. Sorry, guys. Really quickly, I'll flip this to LocalNet. Definitely some gotchas along the way that you guys will figure out. But okay, now that that's set to LocalNet, we're still scanning for logs here, and I can go ahead and do our test, which should be much faster. There we go. And then you can see the logs, right? Our program's ID, payer address, etc. So that's a good little trick to read your program's logs. And just talking about the client-side stuff, this is how you create a raw transaction instruction. And then this is a shorthand function for sending a transaction. This is being deprecated, which is why I didn't show you guys this originally. But for testing, you can use it. But I do advise going with the version method that you saw earlier. But right here, you can see that like here's just the same payload that we've been working with for an instruction. So program ID, we've got accounts. For some reason, it's labeled as keys in this object. I don't really know why. And then data. And so again, no data with this example, but this is how you set up a raw instruction to send to your program. Now, moving on to a more complicated example of a program. So we saw in this one, we're just printing stuff out. So I put an underscore here because we're not even using the instruction data. And for the accounts, I'm just demonstrating how you iterate through them. But let's take a look at this example here where we actually have a program that's going to use different instructions, right? So this is already going to look a little bit more complicated. But the key, and again, you can import into SolPG if you want by just going like this and just flipping to Hello World again, going to the root, taking that link and importing it. So there it is right there in SolPG, guys. And then I will also show you quickly, since I didn't do this earlier, in SolPG, you can do what I did locally. You can hit build. You can see it's pretty fast. we're on localhost, and you can deploy it. And so that will actually build and deploy from SolPG, which is pretty cool. Anyway, let's talk about this code. So to your question earlier, I believe it was Bruno. Yeah, Bruno was asking about inputs and outputs. Yep. So, and then Alexander, the project in VS Code, is it creating using Solana? It's not created using Solana per se. It's a combination of a few things. So it's the code that I shared in the GitHub repo. The client stuff is just JavaScript code, and I'm using the dependencies from Solana. And then the Rust stuff, the hello world and hello world again, this is created using Cargo, which is the Rust dependency manager. So if I just go ahead and do like Cargo new lib my smart contract, that's how you set up a new smart contract. So, and then again, I just added the configs for, my particular, lib type, like I showed right here. You just have to add this, and then you add this dependency. So, but yeah, it's not, you don't have to use Solana to write this. You're just using Solana dependencies. The only thing you need the local Solana setup for is in these scripts. I'm just loading my local key pair. But you can optionally, you don't really even need to do that depending on what you write here, but this is a great way to just like use your local configs to test. But yeah, it's not built using Solana. It's just involving Solana in the build. But anyway, so we're going to talk about the inputs and outputs question that you had earlier, Bruno, and that I'm sure a lot of people are wondering. So, taking a look at this code here for the Hello World Again program, we can see that we've got a number of different objects up here, which I'll come back to. But down here is the same setup we already saw. We are declaring the entry point to be Hello World. And this time we don't have the underscore on instruction data because we're going to use it. And you can see in Rust, what you do is a match statement, but it's pretty much similar to like if else, some caveats, but you can think of it pretty much the same thing. And, considering the syntax here, you can kind of figure out what's going on. Like, hey, if it's this particular variant, do this. If it's this variant, do that, right? So what's happening here, if we ignore this line for now, in Rust, we basically have an enum that we're going to match on, and based on the variant, we're going to run different functions. And then the rest of the stuff is exactly the same as the last program, right? So how do we actually know like what this enum is? Well, up here, I've defined it here. And the cool thing about Rust is you can add the functionality to serialize and deserialize Rust code into byte format by just adding this annotation right here. And to add that annotation, you just need these two dependencies, Borscht and Borscht derive. But it's honestly that simple. Once you add this annotation, what Rust will do is it will implement for this enum all of the Borscht functionality that you're going to need. So for that reason, down here, we can create this variable instruction, and we can use the instruction enum that we defined, and we get this try from slice function that comes from Borscht. And then you can see that obviously we are just running it on the instruction data. And what that's going to do is it's going to take this slice of bytes, and it's going to try to deserialize it into the my instruction enum. And what's cool about Rust enums is your variant can have args in it. And this is exactly where your input output starts to come into play. So you've got this variant takes these args, which are defined right here. And this variant takes these args, the goodbye args, which are defined down here. And what's nice is you can see that these are different, right? Like this one has one field, this one has two. When you run, and since we've annotated each of these with Borscht as well, they're all deserializable. So when we do this, we're going to get one of these two variants and the associated args. And so our program is going to just say, okay, if we get the hello one, we're going to run say hello, and we're going to pass the args. You can see up here, my function say hello is using those args, and then I can just reference them. right? And then same thing with the goodbye function, pretty straightforward. But that's exactly how it looks on chain when you are sending instruction data to a program and it's trying to decide which operation to conduct. So those are inputs, right? Like this is going to be the key right here. Every program is going to have one of these to some degree. Might look a little different, might be humongous, but it's going to have one. The tricky part with this setup is actually packaging this instruction up on your client side and sending it to your program. So in Rust, it's very easy to add deserialization because you just add this annotation and all the work is being done for you. In JavaScript, this is a little bit more of a manual process. So we're going to take a look at exactly what that looks like. Right here in the tests, you can see that I have our test file as well, like we did before. And it's pretty simple, but these functions right here have been introduced, right? So create hello instruction, create goodbye instruction. These are wrapping the manual process that I'm describing. So ultimately, when we do this, we're going to pass in these public keys and the message. And in this case, we have two messages like we saw with the on-chain code, which I'll keep up right here. And then we're going to get back the instruction that we can then send within a transaction like we've seen before. But here's where the tricky part comes in, where we have to basically use JavaScript or TypeScript to create what we wrote in Rust. And so this is why a lot of times you'll see like dApps will leverage a smart contract, and then they'll also have an SDK, because in that SDK is all the code you need to match what's in the program. So here's what that looks like. We start with the enum. It looks exactly the same, right? And I'm actually going to do one of these guys here. See if we can see if this doesn't look messy. Cool. So you can see the enum looks the same, right? Except we don't have the args in there because that's going to happen later. So the enum itself is going to be which variant we're going with. And then let's take a look at say hello. So what you want to do is set up a class for this particular like instruction. So here's the instruction, and then here are the arguments. And if we look at say goodbye, it's the same thing. Instruction, and then both arguments. And the reason you do that is because you write it like this in Rust, but when Rust does the serializing into bytes, this is the TypeScript equivalent of what those bytes would serialize into in TypeScript, right? And vice versa. So Rust represents it a little bit differently than TypeScript does. In fact, Rust does it in a way that's almost a little bit more like easy to use when you get used to it. But in JavaScript, this is the way that it's going to be represented using like an OOP language. So that's why it looks different. But ultimately, you can think about it like here's the variant and the args, here's the variant and the args, right? And so once you set that up as a class, you can use a constructor like this with props and an object instead of just passing them in as parameters. And the reason you want to do this is because when you go ahead and implement this toBuffer function, you'll be able to use Borscht, just like we're using in Rust, to serialize that code into bytes. And you can define this schema, which is going to make it look exactly the same as what it's supposed to look like in Rust, right? So these are the three components right here. So you have your instruction variant, like your instruction enum. You have the class with all the fields, and then you have the schema that it's using to map into bytes. And then right here's the magic function that will turn it into bytes. So I'm going to take questions in a second, but finally you wrap this into right here. You can do a new version of the class. You set the fields, and then you just do for the data field of the transaction instruction, you go ahead and take the object and do toBuffer. And that right there will turn this object into bytes, and it will package it into this instruction, and that will send it to your program where it will then deserialize it and figure out what to do. So this is very manual right now. And honestly, guys, it's good to realize that this is still kind of like a trivial process because this is like brand new technology, right? Like it's only a few years old. So there's plenty of room for iterations on this process. Like there's ways to do this cleaner, to build wrappers around this, to build libraries that help with this process. And there are 2 such libraries that exist already. And I'm going to quickly show you guys what they are. So just want to pull up my browser here. So the first one called Anchor Lang. I'm not going to cover a ton about Anchor here, but basically what Anchor does is it provides a library for Rust and for JavaScript that will do exactly what I just described. It will wrap all that stuff and it'll make it a little bit easier to do. Now I wanted to show you guys the native, like raw way to do this, because sometimes you might prefer to do this for different like design use cases, but you can also check out Anchor for what you guys are building in your hackathon to see if like this might be something you might want to go with. There's also a newer framework called Seahorse Lang. And this is basically going to let you write all of the code in Python and it will convert it into Rust. So both options are valid. Seahorse is actually being pretty well built out lately. So you're going to have like more and more functionalities being added. Eventually, hopefully one day you'll be able to do exactly like anything you can do in Anchor with Seahorse. But just understand that this will turn it into Rust. It doesn't just go right from Python, but still cool to know, cool to use. And Solana Playground supports all 3 as well. If you take a look, you know, you can see that like there's the import instructions for both, and then you can see all 3 are supported by the IDE. So you can use this tool as well, which is really nice. But guys, that's really the core concepts of writing your own smart contract. It's very straightforward in a basic sense until you get to creating your own instructions. And that's where you need to start doing serialization with Borscht. And it looks like a lot of code, and in reality, it probably is, but it breaks down pretty like modularly, right? Like I said, variant, class with fields, turn it into a buffer using this schema. That's really it. And then your test code looks nice and clean like this because you've wrapped it all into, you know, those functions. And again, the source code is all available. I shared the repo link. But yeah, it's a little bit trivial, like I said, but ultimately what you're really doing is just trying to figure out the code that's going to tell your program what to do. It's actually easier to write Rust sometimes, but that's really it. That's the basics of writing Solana programs. And then that'll give you all the building blocks you need to like build more complex programs, probably to build the programs that you're going to need for this particular hackathon, whatever you might be building. So that's really good starter. I'm going to give it a minute for some questions on writing on-chain programs, and then we'll get to the token stuff afterward. So I'll give you guys a sec. Any questions at all on the Rust code, on serialization, whatever it is, let me know. Do you have an object-oriented programming code example? I'm not exactly sure what you mean, Alan. This here is object-oriented code right here. And Rust is not necessarily object-oriented. It's a little bit more like functional, or not functional, imperative. Does the Solana runtime ensure all parameters are correct and valid, or do you have to validate? So basically, it's not going to ensure your parameters are correct. What's going to do that is this part right here. It's going to try to interpret the enum variant with the args from the bytes. So if you have like the wrong data type, this will fail, right? There is kind of an edge case where like it might accidentally interpret the wrong one, and that's something you have to kind of like make sure you're protected against. So, you know, it's good. Well, I guess technically it wouldn't necessarily do that, because with Rust, you've got the variant and the args, right? So as long as you have the proper variant, that shouldn't happen. But if you like pass in a number instead of a string, this won't work. Like it won't give you any of these. So that's how it protects against the proper data types. If you send the wrong parameters, like if you on your client side put the wrong value in here, no, there's no check. The runtime itself will check your accounts. So like if you look at our program, we're expecting our payer. And if we do something like this, where like, say we have like account 1 and account 2, and I mentioned this earlier, if you only pass in 2 public keys and your smart contract's expecting 3, it'll fail. If you put them in the wrong order, it'll also fail. Or no, it won't fail. It'll just do the wrong stuff. And like your signers might not line up. But so yeah, that's really important. If you have too many, like if you have 4 and it's expecting 3, that 4th one won't get picked up, you know? So you have to just remember this is a list and your program depends on the order of it. So you definitely want to make sure that you keep that in mind. Your program itself can check to make sure that certain addresses are the same, right? Like, let's say I want one of these to be like the system program. I can do a little check to make sure that like the system program is what it's supposed to be. You know what I mean? So you can do stuff like that with your on-chain code. But the runtime, all the runtime is really going to do is make sure that you're not trying to write to the same account in 2 different spots, because programs can run in parallel. So like your same code will run, you know, multi-threaded. And so it's going to look at those addresses to make sure that any instance of your program isn't using the same account in 2 instances where it would be writing. It's not going to really check much of your custom like configurations though. That's going to be mostly done with your code. Let's see. Comparison to EVM, what would be the equivalent of message.sender in Rust Solana contracts, and how to capture or create validations on the programs? Message sender. Okay, so I'm not super familiar with writing EVM smart contracts, but I'm assuming you're talking about trying to figure out who sent the transaction. In Solana, it's the fee payer. So you saw on the Explorer, there was a fee payer person involved with whatever kind of like transaction is being sent. In that case, it was this guy here. To send a transaction, you have to pay for it. You have to pay for gas. That is going to be the person who sends it. So message.sender, the equivalent is fee payer. And so in this case, you would want to include that in your accounts list. There's not a way to, like, that's not an additional field that you can just get. When you write a program, you want to also have the fee payer in here. So it's not a default thing. You'd have to add them to this list. So like in the case of our instructions here, you can see that I'm adding the payer right here. You would just do that. So you'd have to just make sure you also add them. And then, are there any perks or unique performance results of using Rust for building on chain? Yes, definitely. So I can't necessarily compare it with Solidity because I don't know too much about Solidity. But a couple things that are cool about Rust is, especially for those of you guys who've never written Rust before, you can see all these ampersands. Rust is very strict on how you deal with memory. So what these are called are references. So if you've ever written like C++ or C, you're probably familiar with the concept of like pointers and maybe some borrowing stuff. I don't know the exact syntax because I've never written C, but Rust is basically going to make sure that you are pointing, like if you're going to point at a value and just reference what its value is, that's a reference. If you're going to actually take the object itself and do something with it, that's ownership. And the point is, in a language like JavaScript, that's interpreted by the compiler, and it's really just making its best guess. And sometimes it's playing to the safe side of just cloning things. So like, for example, if you do like let x equal 5, and then you say let y equal x, then you say y equals y times 2. This will only change y, right? X will still be 5. In Rust, that's not the case. Now, integers are different. In Rust, integers are always references because they're hard-coded, and it gets a little complicated. But the point is, when you do something like this with objects, Rust will make sure that you tell it what you want to do. Do you want y to become the object that was in X? Or do you want Y to just borrow the value of the object in X? And for this reason, you get highly performant smart contracts on Solana. Solana is one big distributed computer, just like EVM. And so when you have memory strict and safe smart contracts, you get really high performance. So it's really cool. And also, like a couple other minor things, like Rust is pretty fun to write. Some of the syntax is cool. I love doing match statements, stuff like that. And there's a couple like quirky things that you guys would enjoy if you're like a little bit of a nerd like I am. But overall, yes, there's a little bit of performance enhancing features that go along with Rust. How should we create? Should we create the project using VS Code or create a project in Solana Playground? So in Solana Playground, good question. What you're going to want to do is you can see here that this is your program, and you can add JavaScript code like right here, and it'll work. It's just a little tricky to import, because if you do like this and you try to import, let's say we want to import all this stuff. At the moment, I don't believe this works. See? So importing code is a little bit tricky when you want to also bring in the TypeScript stuff. And honestly, you guys can, like, this is an open source project. You can pass in that as an issue and see if somebody wants to pick that up or work on it with you. But if you're building this yourself from scratch, you can always just do like, you can just create folders. A little bit tricky to do, I guess, but you can build it all in SolPG if you want. I personally recommend, just because like I love my local setup, I would do it in VS Code, but this is a great tool for just testing your program. And the neat thing is you can actually deploy it like we did down here. And you can go here and get your program's information. So let's see. And you can get the ID of the program, and then you can go ahead and just run your test locally against it. So like if I change this where I have program.public key, if I just do this and I say new public key, I can just pass my program's public key right there from SolPG, and that'll allow me to use my local JavaScript setup to go hit my program, because as long as I'm pointing to the same network, which in this case is DevNet, but we deployed to local net. So once you use SolPG to send your program off to the network, you can use just JavaScript locally to go interact with it, or you can use the built-in IDE to write all your code. Totally up to you. Honestly, it's whatever's easier. If you have trouble installing anything, go with SolPG. But if you, maybe you can install Solana and, you know, Node, but you can't get Rust for some reason, then you can go with VS Code and you can use SolPG just for your Rust code. If you can get all three, Rust, Node, Solana, go local. That's just my take, though. Cool. Anywho, want to make sure we're keeping track of time here so I can cover token stuff for you guys, because you're going to want to know some of it for your builds. So I'm going to jump into tokens. And we skipped around a little bit, but we're going to talk about tokens on Solana, right? So everybody wants to know about tokens. Everybody wants to know about, you know, NFTs and stuff like that. So, and just so you know, the command is Solana program deploy. So let's talk about tokens. So on Solana, tokens follow a standard similar to Ethereum, right? Like Ethereum's got the ERC standard. Tokens follow a similar standard on Solana. It's a different standard. It follows the SPL standard, which I think has a more technical name, but I forget. And basically, the way this thing works is you have an account that represents your token. And I'll explain how the transfers and all this other stuff works as we go. But basically, every token gets created as an account because, like we said earlier, everything is an account, even a token. So when you create a new token, you create a new account, and then you actually set the inner data of that account to these fields right here. And this is the standard for mint data, right? So is initialized, has the data been initialized as a mint? Is this account a mint? The total supply, the decimal places for the supply, and then the two different types of authorities. So quick note on decimal places. You can see I put the calculation in here. Basically what that means is it's how your supply breaks down. So you can see it's quantity times 10 to the -1 times decimals. So in layman's terms, if you have 3 decimals and you want to, let's say, mint 5 tokens, that's actually going to be 0.005, right? It's just like you're taking the decimal, whatever number decimal place is over. That's all that means. With an NFT, it's 0 because if you think about it, 1 is 1, right? Like 1 NFT is 1. So this is the standard right here. These are the defaults. The typical SPL default is 9, and the typical NFT default is 0. You can decide to use whatever decimal place you want for your own token. But if you want it to be an NFT recognized by like most wallets and explorers, you need to use 0. So anyway, what file are we deploying in Target? If you have questions, throw them in the questions tab. It's easier for me to track. But this is when you build with cargo build BPF, you will get target deploy program.so. I don't know why that came up as a link, but that's what you'll get. Anywho, so going back to tokens. So yeah, and then the authorities down there, pretty straightforward, right? So mint authority is the one who can mint new tokens, who can introduce new tokens into the supply. And freeze authority is the one who can actually freeze the movement of these tokens. And what that basically means is like they can't be transferred, they can't be, created more of, you can't do any of this stuff. It's frozen in place. So pretty cool stuff. When it comes to NFTs, you can disable the mint authority. So you'd mint one and then disable the mint authority, and that's how you get a non-fungible token. There's no other token in supply. And when you disable minting, that's irreversible. So it's by design, so you can have NFTs. So basically an NFT is you create a token, you mint one of them, and then you disable minting forever. And you have a non-fungible token. One supply is one, that's it. And we'll see that in the code. So on Solana, this is where things get a little bit different than maybe some other chains. You have what's called associated token accounts. So we saw the default fields in like a typical Solana account, like your wallet, for example. And one of them was LAN ports. And that's because LAN ports or SOL is the native token. But think about it. If anybody can create an SPL token or an NFT, how would we possibly add, like the balance for every single token that lives on Solana? How would we add all that to like a default account? Like you really can't, right? Because like there could be unlimited numbers of them. So what you want to instead do is you want to instead have a separate account called an associated token account. And that token account is basically going to point to the mint that it's for and the wallet that it's associated with. And it's going to track the balance. That's literally all it's designed to do. So it's just like an intermediate account that says like, here's the wallet I'm for, here's the mint I'm representing, and here's the balance of that mint in this wallet. And that's exactly why it's a separate account, is because when you create a new token, you can create a new associated token account, and so on and so forth. So that's how those things work. And following the similar format is the metadata for a token. So we saw like back on the mint here, these are the default fields. So in order to introduce like a picture and a symbol and a title and all these other things, you need to create an account for metadata. And this follows a metadata standard provided by Metaplex, which we will also see in the code. But the point is, it's another separate account, and it points to the mint, and it describes all of the associated metadata for it. And this is a standard across Solana, which is why explorers will be able to load this metadata and you can see it. So pretty cool stuff. So let's take a look at this stuff in code and we'll see exactly what I'm talking about. And then we'll even look up some of this stuff on the Explorer as well. Looking at questions real quick. Do I have good references for token 2022? At the moment, anything outside of like the docs that they wrote for 2022, I don't have. But I can maybe circle back to this later on. So anywho, going to our scripts again, you can see that we've got tokens here as well. So let's take a look at a couple different functions. So if you look, here's the different functions that our script is going to do. So we're going to use create account again. And these are just going to be some test wallets that we're going to work with. And then we're going to create a new token with 9 decimals. And that's going to be an SPL token. We've got a title, we've got a symbol, and then we've got this JSON that I'm pointing to, which this is where you would put like IPFS or like Arweave, which are like file storage sites, like clusters, where you would point to your data being hosted there. In my case, I just have it hosted on GitHub, and you can do that by just putting it in your repo like this. And then once you push it to your repo, you can just reference it with the raw data like this. So kind of a neat trick for testing. But that's what I'm doing for both of these. And then you can see here, I'm also creating a token as an NFT, which is going to be 0 decimals. Now, notice I put these in the same function. It's because both are tokens. Both of them are SPL tokens. But because they have different decimal places, they are going to be different types of tokens. And when I actually pass in the mint, you can see down here when we're minting with the mint, this is one example of how to do it. You can do this a number of different ways, but I'm going to mint 1 to my wallet, and then I'm going to disable minting like I talked about earlier. So here's minting 2. We're introducing new tokens to the supply, and we're minting them to somebody's wallet. And then here's a transfer. So we're going to transfer 10 tokens, or we're going to transfer that NFT. So we'll see what those look like. To start, creating a token, I wrote again about the decimal places. Creating a token looks like this. So we first want to create an account for the mint, right? And again, I'm passing the mint in as a parameter like we saw previously. So same step as creating a normal account, right? We still have to have an account on chain where this mint is going to live. The difference though is look who owns this particular mint. The token program, not the system program. That's because the token program needs to have the authority to be able to change this account. So because we're making it the token program the owner, that is one of the requirements for it to be a valid mint. Another thing too is we're allocating the size of this account's inner data to fit that mint information, which we saw here in the slide. You got to be able to have enough space for this stuff. So that's what the mint size constant is for. And obviously we're grabbing the rent again, like we saw before. And then here is a good example actually of packaging multiple instructions into one transaction. You can see there's all 3 right there. So we'll get to that in a sec. Here we're going to initialize the mint. This is going to write the data to that inner data. This is going to write these fields into the account, right? And set it as initialized, which is what this top field is saying. So that's the instruction to do that. That instruction is to the token program. This function comes from the SPL token library, and it'll package it up for you. So you're not actually telling it it's for the token program, but it's being done under the hood for you. So that's pretty cool. And then finally, when you do the metadata, you're going to create metadata. This instruction is again provided by a function, but this one comes from Metaplex, who is in charge of the metadata standard on Solana. So you can see that they have a function as well that will give us the necessary instruction to create metadata. The tricky part is their function takes in these big objects, and it's a little bit trickier. You can see that like the 2 Solana ones are just these like straight up fields, but this one takes, these are the accounts and these are the arguments. And the reason it's set up like this is because the concept of metadata using Metaplex on Solana goes well beyond the scope of this tutorial. I'm just showing you the basic fields to get like a title, a symbol, and a picture. But there's way more stuff that you can add. Like you can see I have null for creators, and I have 0 seller fee basis points or royalties. There's other stuff that you can add as well. You can create collections. There's tons of different versions of this metadata. So, you know, something to note is it looks complex because there's a lot of expanding you can do on this. Like you can add more accounts, you can add more arguments. Pretty cool stuff. You can also make your metadata mutable, which is interesting. But in this case, this is the default for just getting the simple stuff. And you can see here this is how you derive the address for a metadata account. And this is important. This is a hash using the program ID of the metadata program, the string metadata, the metadata program ID, and your mint's address. Now, the reason you do this is because this is the pattern. And if you don't get this right, the program will throw an error and yell at you. This is how the account knows what mint it's for, because it's being used right here, right? So even though none of this data has our mint in it, it's being used right here and also here. But you can see that this is used to create the actual address of the metadata. And then things like wallets can use this same function to get the metadata for your NFT. And that's how that works. That's called a PDA, and that goes a little bit beyond the scope of this tutorial as well. But this is the hash function that is used to create those. So building a transaction with all those instructions, we got a list of all three of those right here. And then we go ahead and send that transaction. And the cool thing is when you include multiple instructions, it will execute them in order. So we're going in this order: create the account, write the mint data, create the metadata account, right? And since we include them in that order, that's the order that they operate, which is pretty cool. So once that's done, we'll be getting a new token. And then here we're minting to a wallet, which just means we're creating new tokens. So you can see, again, using some SDK functions to create these instructions. So this is key here, right? Like we talked about token accounts, and we have to actually make sure that they exist before we can try to like transact with them. So this function, get or create, will do exactly that. It'll look up, see if it exists. If it does, grab it. If it doesn't, it'll create it. And so since it's doing that, it's sending a transaction. So you're going to include connection. You don't have to do it this way. If you want to still package your instructions all into one transaction, there is instructions that you can use to like create these token accounts, and you can use RPC requests to look them up. But this is a cool shorthand way I thought I'd show you guys of how you can get or create them. So you want to do that for the recipient, and we are minting too, so there's no sender, right? So we're just going to do that to get the recipient's token account. And then we're going to create the instruction to mint to that token account. And if you notice, the key is like we're minting to the token account, not to the wallet. So this is something to remember when you're setting this up. And once you do that, you send the transaction just like we've done before. And right here is where I'm adding the instruction to disable minting if it's an NFT. So I've got this optional parameter that I'm passing in down here when we do mint our NFT. This is just one demonstration of how you do this. But right here, it's going to create the set authority instruction, and it's going to do mint tokens, set it to null. And that's irreversible. These cannot ever be minted again. The reason why it's irreversible is because the mint authority needs to sign off on this operation. And once you set the mint authority to null, there is nobody to sign for it. And it's by design so that no one can ever undo like the creation of another NFT, right? Then it wouldn't be NFT. So kind of cool. And then transfer, we're doing the same stuff. We're creating token accounts if we need to. And then we're doing the transfer between the token accounts. So not the wallets, but the token accounts. So let's give this a run. And we'll take a look at some of the outputs there, and we will find them on Solana Explorer. So one thing we're going to see, so DevNet is down, it looks like. So this is probably not going to work the way I want it to. But if I change this to localhost, I'm going to show you guys what I meant about the custom programs. So because the Metaplex program is a program that was created by Metaplex, it does not exist on the local validator. So I want to make sure our configs are set there. So when you run this, you're going to get a problem with trying to create the metadata. See, attempt to load a program that does not exist. However, if you were on DevNet, this would work because it does live on DevNet and Upward. So what I'm going to do is I'm going to actually just omit this for now, so we can take a look at some of the output. But if DevNet was up, I would be able to show you guys how like the pictures come up on the Explorer and stuff like that. But you can see here's the output, here's the balance transfers and the mints and stuff like that. And then we can still look up these tokens on Explorer. It's just they're not going to look as pretty. So let's take a look at like our SPL token. And you can see that there's the decimal places being put into play there, right, with the current supply, decimal place of 9. Then here's our NFT. It's just going to come up as a token right now. But once you add the metadata to it, the Explorer would know it's an NFT. So pretty straightforward, guys. And then if we want to take a look at a associated token account as well, this is what they come up as on the Explorer. You can see it's a token account. You can see the mint that it's for, and you can see the wallet that it's for, and then the token balance. So just like I showed you. So that's how you work with tokens. I wish the DevNet was up so I could show you the metadata part, but this right here is how you set that up, and feel free to explore this some more. But hopefully the concept of like the separated accounts for tokens makes sense to you guys. If there's any questions though, let me know on the token stuff. So Maxim's got a question. Are all the associated accounts proper accounts, i.e. do they also have a balance, like a Lamport's balance? Yes. So every single account, no matter what it is or what it's for, has those default fields that we saw in the beginning part of the slides right here. Every account has these. Where they start to be different as far as what they're for is just that data field. That's it. So smart contracts, associated token accounts, mints, wallets, all of the above, they have a Lamport's balance, they have an owner, they're marked as executable or not, and they have a rent epic. And they also have data, but in that data is where those things differ. So the data of your wallet is going to be 0. The data of your mint is going to look like this. And the data of your smart contract is going to be the Rust code that you put into bytes. So hopefully that makes sense. Go ahead and ask any other questions, guys. It is a Homer NFT. Yeah, the picture is supposed to be this right here. It's funny that you went and grabbed that. It's supposed to be this picture right here where you just go ahead and this is, I'll show you guys a little tip here that I do. It's just Homer. But this is a cool way that I go about testing token metadata is if you go to Google and you just search for an image, you go like this. I don't recommend doing this for any productionalized NFTs for copyright purposes, but if you hold command on or control and you do open image in new tab, as long as the URL ends in a file type, which this one doesn't, but you can see this one does, like .png, it'll work. So, and like I said, I put it in GitHub here, and then I just click raw, and it's just the raw JSON, and you can just copy that into your code here. Wherever I put that metadata, right here. So that's how I did it with GitHub. Just like a cool way to do like a quick and dirty NFT. It's nothing really crazy. Typically though, this URL is where you'd want to have like a decentralized file store, which you can read more about on Arweave or IPFS. So another question, Maxim, can you explain the thinking process why we don't just store the account balance map inside the data field of the mint account? Why create all of these accounts? Trying to make sure I understand your question correctly. So why don't we store the balance of the token inside of the data for an associated token account? Is that correct? You can say yes in the chat if that's correct. Yeah, if that's your question, the answer is we do. The balance of a token is stored in the data field. The only balance that's not is the Lamports. I see Maxim is typing. That's what I'm waiting for right now. Sorry, guys. But if anybody else has any questions, throw them in. That was everything that I wanted to cover today. Those are all the basics, all the building blocks. With these code references and some of the links and everything we talked about today, it should be good. That should be all good building blocks for you guys to build most of what you want to do with the hackathon. So definitely take a look. You can reach me on Telegram if you have questions. Soul Joe. And then Maxim, I saw you replied. It makes sense to store the account balances inside the original Mint account, not create a new account. That wouldn't necessarily work because you'd only be able to store the balance for, like, you'd have to create a new field for each person's balance. Like if you have a token and let's say it's an SPL token you're going to have like 1 million of. Let's say you have 1 million people holding this token. Let's say it's USDC. How are you going to store 1 million people's balances in the Mint account? You know what I mean? It's so it can scale. So your associated token account is per wallet. Like it's 1-to-1 with your wallet. And it's 1-to-1 with the Mint. So it's a 1-to-1 relationship between both those things. It's basically a bridge connector between your wallet and a Mint account to record the balance, you know? So that way, if I mint someone else these tokens, I don't have to update the Mint account. I just create them an associated token account. Otherwise, your Mint account could end up being huge, you know? It's not possible to get all holders from the token account, right? You have to go through all the transactions. No, that's not true. So I showed you here how, and I teased this a little bit because it's a little complicated to go into in a beginner workshop, but I showed you here how you derive the metadata address. You can use the same function to derive the associated token address. So as long as you have the person's wallet address and the Mint address, you can get their associated token account using this hash function. The tricky part is figuring out what your list of wallet addresses is supposed to be, right? Like if I have the Mint address for USDC and I want to know how much USDC everybody in this chat has, I need everybody in this chat's wallet address, and then I can figure it out. But if I don't have all your wallet addresses, then there's really no way for me to know. You know what I'm saying? Bingo. Yeah. So no, you don't have to go through transactions unless you don't have wallet addresses. Yeah. Like for example, if you like a wallet, like a Phantom wallet or something like that, it has your address, but it doesn't know what mints you have. So it does go through kind of a expensive function called get program accounts. And basically what it will do is it will run a query against the token program with a filter for your wallet address. And then it will only return all the token accounts that your wallet has. That could be a little bit taxing sometimes though, but that's how they work right now. So there's ways to do it. You don't have to go through transactions ever. The way that addresses on Solana are derived are deterministic for the most part, with the exception of Keypairs. Keypairs are generated, but anything that's like a program-owned account, like a Mint or an ATA, that's derived with a hash function like you're seeing right here on screen, and you can use that hash function to your advantage. Is there something that handles kind of like the graph? I don't know too much about the graph, but I think the closest thing you're going to get is what I'm kind of describing of using. You can use get program accounts and you can use derived addresses. And the combination of the two is you can kind of have like a mapping. It's almost like a hash map. So one way to think about it. But like, for example, if you look at this metadata one, like I have the Mint, I can get the metadata just by running this calculation, and the program ID is a constant. A lot of data accounts work like this. So you can use similar functionality to get accounts that you don't have the address to, because you can derive the address. So a little bit different than like a graph setup, but it definitely, you don't have to just like iteratively look through everything all the time. Again, shared my Telegram. If you do have questions or you run into problems in your build, I'm happy to help you guys out. Throw any questions in Telegram that you have. You might have to send me a friend request first or something, but just hit me up. I was at Hackathon. Yeah, I was at Hackathon in November. Pretty cool. If I met you there, Maxim, that's pretty awesome. Good to see. I had a great time at Hackathon. I think it was a great event, and everybody I met was super cool. But all right, cool guys. Thank you very much. I appreciate the time. And again, hit me up with any questions you have. But hopefully you guys learned something. If anything's confusing at all, just hit me up. And hope to see what you guys built.
Cool. Thank you so much, Joe, for that awesome, like, massive crash course on everything. Yeah, so to everyone that's still here, we will be in touch tomorrow with these workshop materials. Just a reminder that our next workshop is next Monday, and that will be on an introduction to Solana Pay. Finally, thank you all for coming. I'm just dropping my Calendly link in the chat. So if you want to book a one-to-one call with me, you can do so. And yeah, I hope to see you guys soon. And thank you again for coming.